Discussion will focus on the technology impact and use cases. They'll talk about real-life case studies of futuristic technologies. Please put your hands together to welcome our moderator for the panel discussion, Mr. Sridhar Chunduri, to the stage. Sridhar is SVP and Head of Technology Enterprise Functions, Wells Fargo. He's been in the information technology world for about 25 years and drives results in multiple areas, including IT services, engineering systems, product development, retail, commercial, insurance sector, and is now with the banking world. Welcome, Sridhar. Our next panelist is Mr. Rajesh Durdu, VP and Practice Leader, Blockchain and Cybersecurity, Tech Mahindra. Rajesh leads blockchain and cybersecurity practices for $5.4 billion IT giant Tech Mahindra. He guides a team of 500 highly accomplished cybersecurity professionals empowering global customers in EMEA, APJ, and India to strengthen their enterprise-wide cybersecurity posture. Joining them on stage is Dr. M.V. Panduranga Rao, Associate Professor, IIT Hyderabad, a PhD from the Indian Institute of Science. Mr. Panduranga Rao's area of expertise include theory of computation, computational complexity, probability in computing, quantum computing, quantum cryptography, applications of the Markov chains in computing. Welcome, Dr. Panduranga Rao. And we have our final panelist of this panel discussion, Mr. Sandeepan Chattopadhyay, Managing Director and Chief Executive Officer of Shelpmock Design and Tech. He holds a degree of Bachelor of Statistics from the ISI Calcutta and is responsible primarily for the performance and supervision of technical, administrative, and day-to-day operations at Shelpmock. And I'm sure I'm not saying the name correctly. Correct me if the pronunciation is Zelpmock. Got that? All right. Welcome to each one of you, and over to you, Sridhar.
Thank you, Shobhana. And I realize Ramesh doesn't close a session without the selfie. Whenever there is a selfie, I know that the session is over. So, Ramesh, thank you. It's a great honor to have a distinguished panelist here, Mr. Rajesh, Mr. Rangarao Garu, and Mr. Sandeepan. Sorry, I have a friend called Deepanjan. I keep remembering Deepanjan more than Sandeepan. All right. I think the previous conversation was more around trying to bring together vertical and business together. But now we really want to talk about the real-life situations and how we can leverage technology. I want to start with Sandeepan. And Sandeepan has been a pioneer in the mass market problems, and you have been working on this for the last 10, 15 years. So Sandeepan, can you really talk about what you have done so far in the mass market problems?
So as basically the point is that there is a dichotomy. The kind of audience that we have for mass market contradictorily is more akin to be usability of high tech than the normal market. So for example, a speech-to-text is supposedly a high-tech industry, and for the normal masses, it's not really a thing because most of them are literate. But when you go to a farmer, that could be a life-saving thing for him to be able to use it for his daily usage. So contradictorily, as I said, a lot of the high-tech ends can actually mean that the mass market people can start using compute and not just become content consumers. So that's the overall synthesis of it. So if you look at the primary movers, what is human and how can that be done? These are the basic foundations of that. So the basic human trait is it has a level of being underwriting, and it's more asset-driven. Now, in the digital world, the identity of it is equivalent to the underwriting part of it, and information as collateral becomes the equivalent of, let's say, that foundation. These are the premises. The use cases, as I said, I was like just CTO for about 10 years. And what we did was we enabled MSMEs to be at the same war footing to get prominence and knowledge of consumers onto that part. Currently, for example, one of our startups, Mihoop, is the one powering all the Tata cars for the voice communication with the card system, replacing things like Nuance or Google and all. And it was built for India so that it works in an offline mode. It understands vernacular languages. It understands dialectic inflections, which often things which are developed in other countries without the right training set cannot grab and do it. A simple use case that we have also used in voice, again, I'm just taking on that, just to give a tip of the iceberg, is for a mass market approach for the government of West Bengal for catering to farmers, where we take a call center and we just use text-to-speech to read out the answer instead of making it happen on an app, and that makes it more usable. So sometimes it's very simple. You just put in the right aspects and approach a simple problem.
Got it. Thank you. And Rajesh, you've been a pioneer on the blockchain technology and also on the cybersecurity front. Obviously, blockchain has been there for some time now, but the realization of it has been in the recent past.
Right.
Typically, people tend to relate blockchain and Bitcoin analogously, right?
Right.
So can we really extend the blockchain philosophy and get more real-life use cases in other areas like manufacturing and pharmaceutical and in other areas?
Yeah, absolutely, Sridhar. In terms of, you're absolutely right. Bitcoin and blockchain are used interchangeably, as is the case with Xerox and photocopying, right? Because since Bitcoin has been the first commercial application of blockchain, a lot of people refer to blockchain as Bitcoin. But there have been a number of implementations apart from cryptocurrencies. We see that in India also to a large extent. If you look at organizations like MeitY or organizations like Niti Aayog, they're putting a lot of emphasis on blockchain adoption in areas like benefits administration, in areas like asset lifecycle management, vehicle lifecycle management, in areas like benefits distribution, titles management, and so on and so forth. And if you look at the recent paper that MeitY had published, they basically want to incorporate the blockchain layer into the payment stack that India has, the unified payment interface, the Jandan, Aadhaar, and Mobile. When you have put all these together, it has led to a lot of fintech revolution and a lot of digitalization that has happened. So today what happens is there's a lot of data which is available, but there has been a missing piece in this. The missing piece is the proof of that particular data, the provenance of the data, and also in terms of validating the documents that are there on the chain. So now MeitY wants to bring in a blockchain infrastructure and make it all pervasive. So the data that is powering decisions can also be validated, and the provenance of that particular data can be established. And during the pandemic, we have seen that there's been a lot of trust gap, not only in India, but also in the world. So blockchain is playing a major role to address that particular trust gap, whether it comes to vaccines, validating vaccines or validating COVID medicines, or validating the vaccination certificates, which have now become quintessential for movement from one place to another place. So there's a lot of blockchain adoption in non-financial area and in non-payments area.
Got it. And Rajesh, I recollect you also worked with Troy on some of the support we can give to the population around spam call management.
Exactly.
And you also worked with the telcos. So can you tell us a little bit about the story? Because to me, that's a real life use case.
Absolutely. Absolutely. In fact, this recalls, the last panel that I did before this panel was in Phoenix. And the Forbes editor had asked me saying that when will the time will arrive when you can go to a neighboring store and pull out a lettuce head and can validate whether it has been genetically modified or not using blockchain. So I told Michael, the Forbes editor, saying that I don't know, but if you come to India and if you are getting a call, we can tell you whether it's a spam call or a non-spam call using blockchain. That's the implementation that we did in India along with the telcos. We are insulating today about 800 million subscribers from spam calls and spam text from the regulated telemarketers. Today, you still get a lot of spam calls, but those are unregulated telemarketers. They are fly-by-night operators, and we are able to detect them easily, which was not the case before blockchain was implemented. So this is one use case which has impacted the common man. which made blockchain real. And it is also the world's leading implementation of blockchain. Anywhere in the world's leading implementation of blockchain, because it insulates about 800 million active subscribers from spam calls and spam texts. That's the implementation, Sridhar.
Excellent, excellent. That's a noble cause. Thank you.
Yeah, thank you.
And Professor Rao Garu, you've been in the computer science engineering world for a long time. As a professor at IIT Hyderabad, you pioneered a lot of work around quantum computing. You are associated with the computer science department and the AI department as well. A lot of credentials, so thank you for coming here and talking about quantum. This is a new field, and obviously real-life use cases are probably out there 10 years from now. But it is important for all of us to know what quantum is and how we can leverage on the longer run.
Okay. In a nutshell, quantum computing is basically a paradigm which attempts to harness the idiosyncrasies or the peculiarities of physics at a quantum scale. So, at a very microscopic scale, our universe behaves in a completely different manner, right? So there are certain established phenomena in quantum mechanics, like there are things like entanglement, there are things like superposition of different states, and so on and so forth. And the question is basically, can we leverage some of these phenomena that are kind of found at the quantum scale to speed up computation? In fact, the question started when there was this very popular and famous physicist called Richard Feynman. So he wanted to, he was he was kind of a very prolific genius. So he asked this question as to, is it possible to, simulate physics, particularly quantum physics, using the classical computers, the semiconductor-based computers that are still existent at the moment. It turned out that the answer to that was not straightforward. It's not easy to, he could not figure out a way of simulating quantum mechanics using classical physics. So at that point, he asked this converse question. Okay, fine, you cannot do this, but at least can you, so therefore, is it possible that you build a quantum computing model? Right? You have, for those who are familiar, there in the classical computing, there are these notions of Turing machines, circuit-based computing models, and so on. So, can you define analogously, can you define models of computation on which it will be possible to design efficient algorithms for problems for which we don't as yet have efficient classical solutions? So, to summarize, basically, it's an attempt to harness those quantum mechanical phenomena to speed up computation, do something which is better than what we can do in classical.
Yeah, thank you. And obviously, speeding up the compute power would lead into the cyber situations that we currently face. Even with the classical computing, we have a challenge, but come quantum, it's probably going to compound much more. Want to hear from Rajesh, what would be the positioning of us from a cybersecurity standpoint to manage the bad actors, especially with the tokenization and the crypto associated with it?
Yeah, sure. So there are two things that both blockchain and quantum can contribute from a cybersecurity perspective. If you look at the cryptography algorithms that are there, they are based on what we call as the trapdoor mathematical functions. A trapdoor mathematical function is a function where the classical computers can verify the output, but they won't be able to decipher the input that went into the calculation. And that's how all the cryptography algorithms that are used in the cybersecurity are being used. If you take RSA, or if you take advanced encryption standard, digital encryption standard, they're all based on the trapdoor mathematical functions, which the quantum computers can break. Having said that, the greener side of that is they can also further strengthen the algorithms. You can do a key distribution using quantum. There are already startups today which are developing quantum routers, and they have demonstrated that any data that is transferred on the optical fiber over 100 miles distance cannot be intercepted. Even if you put a packet sniffer, you won't be able to intercept those data packets. So that has come into existence already. Now coming to the, and one more point on quantum, while academically they say that quantum can break these algorithms, we've done some analysis where you would need the number of logical qubits and the physical qubits. Today you have computers which have about 50, 60 qubits. But if you have to break the cryptographic algorithms, the logical qubits go to an extent of about 5,000 logical qubits. So we still have to get to that particular scenario. So it is still many, many years away, but academically it is possible, but technically not possible. Now coming to blockchain, if you see, most of the cybersecurity practices are based on the centralized concepts. So what you do is you basically secure your centralized infrastructure, and then when there is a DOS attack, distributed denial of service attack or a DDoS attack, they come from multiple vectors and then bring down the centralized infrastructure. So there is no fallback option. There is no failing option, fail-safe kind of an option. But when you architect on decentralized technology, which blockchain or a distributed ledger technology brings to the play, then even if one infrastructure is brought down, the redundancy comes from the other infrastructures. That's how blockchain and distributed ledger technology is going to rewrite the cybersecurity practices. Are we already seeing? Yes, we are already seeing in the area of identity and access management. Two things are going to be pioneered, or rather they are already being implemented. One is what we call as the passwordless authentication. If there are no passwords to authenticate, then there is not going to be a phishing attack. What will the cyber actors go after? So there is no option to harvest those credentials through the phishing attack, number one. So there is going to be passwordless authentication, which will also bring in what we call as the zero knowledge proofs. So in identity and access management space, we're already seeing a lot of blockchain implementations. And another area where blockchain can play an important role is code provenance. We have seen all the major cyber attacks have happened because these cyber actors have triggered unauthorized updates pertaining to the software. So if you're maintaining the main software on a blockchain and that proves the provenance of the code, and when a person triggers an update, all that they need to do is to compare that update with the code provenance which is maintained on the blockchain. If it tallies, you trigger the update. If it doesn't tally, you don't trigger the update. So these are fundamental changes that blockchain is going to do to the world of cybersecurity, Sridhar.
And just adding to your point, are the encryption standards going to change, although quantum is still far away? Do you expect in 3 to 5 years the encryption standards getting a version?
No, the encryption standards are not going to change. For example, there's only one cryptography which is at a risk, which is called as the RFC cryptography. It's also called as asymmetric cryptography, where the private and the public keys are different. That is what we use today for internet communication. But when you're storing your information, you use what is called as advanced encryption standard, AES 256 and AES 512. They're also called as the military grade encryption standards. And there are papers available where it says that that encryption standard cannot be broken even when quantum comes into picture. Then there is one more encryption standard called ECC. They use elliptic curves for that particular encryption. And that is, the key size is a little laborious, but that cryptography is quantum safe even today.
Sure, thank you. And Sandeepan, switching to the classical computing world again, in terms of the cloud adoption, overall IT spend versus the actual adoption is roughly 14% in US and around 7% in India. How do we really improve that? Obviously, it helps us in a lot of ways, be it on the scalability or also on the security point of view. So what are the things we can do?
See, cloud is basically a quick way of getting running and being able to scale up on demand. I think the nature of innovation drives the purpose of cloud. So the more innovative a society, the more the need for the cloud. As things stabilize, you actually will get more optimal parts of it. But for countries with demographics like India and sociographic patterns like it, there is a case for a kind of a public cloud which is sovereign cloud. And if you can see the current things like this JAM's entire part of it, it's actually a public cloud infrastructure which has made this entire propagation possible. So unlike normal things, the fastest company to reach 1 billion subscribers was Reliance Jio, just because it had the backbone of that public cloud to serve the next level of that part. So that triggers that part. So cloud is more like tsunami. One level of cloud done at a fundamental level can ease the next level to come in at a much faster level. And that's exactly where it's self-propagative and fractalized. That said, at the same time, when you have settled onto some part, there is a cost benefit in not being on a public cloud where you are not paying for the infrastructure, but actually coming down to an optimized, maybe a private cloud or a hybrid cloud situation to optimize your costs. So it's a case-wise thing, but cloud essentially is more like infrastructure as a service, and as was talked in the previous thing, the service element being the main aspect. That leverage of cost-benefit ratio is what will determine that part.
Excellent. And you also worked in Aadhaar group to really support the data privacy. That's an interesting engagement that you went through. It's a massive implementation.
I guess everyone who was in some sort of a data format senior
worked
position was drafted into that volunteer
Yes.
group. But yeah, I mean, the knowledge we learned that when we went from real theoretical knowledge to field, like retina scanning was not in the first part. But when we went to the villages, we realized that people who work hard, they have so much chalas in their hand that you cannot get thumbprint in many cases, especially if they're daily wage workers and all, and they're the ones who need that transaction on a fast basis. So you had to have one more layer of it. And again, it was built for not 100%, but a tolerance level which is cost beneficial to that. But so we had to make new rules given our demography and economic situation onto that part. So yeah.
And the question around sovereign cloud keeps coming. Is it a real need from a country point of view? Or should we say that, hey, you know what, with all the checks and balances on the public cloud, you can still live with it?
What is public cloud is debatable, right? I mean, the internet is basically nor public nor private, it just exists. But if you look at it, sovereign cloud, in a way, has been the reason why the internet exists today. We talk of the ARPANET, but there was a MILNET. The military network was essentially a sovereign cloud, which essentially got the entire TCP IP stacks and everything working. So somewhere or the other, when it comes to national security, when it comes to making sure everyone has equal access, and somehow the cost is borne by the sovereign, I think from a socialist point of view, sovereign cloud needs to be there. Someone needs to bear the cost. Now, technically, if you are leasing a cloud space from the government of India on a so-called public cloud provider, it still is a sovereign cloud in my opinion. So it's more of a structure where the taxpayers' money is making sure that every citizen has equal rights of access. From that perspective, it's a sovereign cloud. It's more of a structure than really an infrastructure in that sense.
Excellent, thank you. And Professor Rao Garu, there is a lot of effort on the quantum side, but again, it's in the nascent stage and the hardware is still in the making. Obviously, multiple providers are competing with each other, be it the Googles or the IBM, Alibaba. So curious on how it is today in terms of the hardware, and obviously there are 200 plus startups across the world working on the software side, majorly on the software side, and around $33 billion plus invested so far. And compared to last year, this year they have doubled the investment. So it seems like there is a sense of realization of quantum itself. But fundamentally, can we talk a little bit on the hardware aspect of it, where we are?
So the hardware, as you rightly pointed out, is kind of in the nascent stage. It's nowhere, for instance, where the current classical hardware is. Like Rajesh Garu mentioned just now, so there's this notion of physical and logical qubits, right? So there's logical qubits are essentially those qubits which you can actually gainfully use. So there's an entire paraphernalia of other qubits which are used for error correction and to just keep this thing going. So in that sense, we don't have a scalable quantum computer. So there are several, I'm not a physicist by training, but there are several technologies that are currently being used, some superconducting qubits. There is something called Josephson junction based quantum computers. There are computers based on nitrogen vacancy, ion traps, various technologies are kind of being concurrently tried out. So depending on the expertise that the physicist has, for example, if suppose somebody is an expert in optics, quantum optics, so he tries to use that particular technology to actually construct a quantum computer. Somebody is expert in superconducting and condensed matter physics, he'll use that expertise in order to design and develop a computer. So there are several groups, several companies, as you rightly pointed out, which basically use all of these above mentioned technologies to kind of construct their interpretation of what quantum computer is. And so many of these companies, there are several companies like Xanadu, there is of course D-Wave is there, which gives you a quantum annealer, right? It's basically some kind of computer which does optimization for you. So a lot of optimization problems can be solved on such things. Then Amazon has, and so on. So many of them are also providing these platforms for other folks to use and try out various applications and so on. So the hardware is slowly maturing, but again, as Rajesh Garu pointed out, it's not clear whether at what point in time will we reach to a position where we can, for instance, do integer factorization and break RSA. That kind of, it's like there is enormous progress, but there are skeptics also who say that it may be at that level the noise and the decoherence will be such that you'll not be able to manage. So it's like dicey at the moment, but we are living in a very, very interesting time. This is the point of inflection. From here, if the scaling happens, I mean, then the sky is the limit. So
got it. And anything you want to add, Mr. Rajesh?
Yeah, so taking on what Panduranga Rao Garu said, in terms of if the audience wants to experiment with quantum, you can get Q accelerator from IBM. IBM quantum offering is called as IBM Q. You can get about 5 qubits without any charge. And they give you an accelerator which can be accessed over the internet. You need to learn a language called Qiskit to access that particular thing. Then Google is also giving, they have Sycamore and the others. So today you can experiment it. But why do we need quantum in today's life? We need quantum in today's life because there are 3 or 4 sticky problems which are still not solved. In the field of sales, you wouldn't know where to put the traveling salesperson. The traveling salesperson problem is still not been cracked. Similarly, in airlines, for optimal routing, they need hub and spoke model. And they've not been able to come up with an optimal hub and spoke model when it comes to managing their operations in an efficient basis. And drug discovery in the current pandemic, when you have to model the drugs, again, quantum computers play an important role from a gene sequencing perspective and from a drug discovery perspective. So already there are 3 practical problems for which quantum computing would be required to a large extent. And then people fascinate in terms of, with quantum you can do teleportation. So all that stuff we saw in Star Trek is going to be a reality when quantum comes into existence. When it comes to existence, then maybe we can do this panel through a teleportation.
So, so a couple of, just to add, a couple of cautionary notes. One is that this TSP, the traveling salesman problem. So there is this class of problems. For those who are from computer science here, they would know that there is this class of problems which are difficult, NP-hard problems and so on. So at the moment, although it's not proved, it's not mathematically proved, it is strongly suspected that quantum computers may not be able to solve NP-hard problems as such efficiently. But it's that, again, for those who are in the know, so there is this class of easily solvable problems called P, and there is this class of problems which we believe are not easy to solve, which are NP-hard problems. So there is that sweet spot between P and NP, and integer factorization happens to fall in that at the moment, if P is not equal to NP, of course, that is the basic assumption. If P is not, that also is not known, by the way. So if the class of class of problems in P is not the same as class of problems in NP, then there are these problems like integer factoring, etc. Those are the sweet spot problems which quantum computer scientists aim for primarily. Well, teleportation at the moment, I mean, so Star Trek teleportation is somewhat in the distant. Right now, the teleportation that has been demonstrated is basically you teleport one qubit, quantum bit. You can transport quantum bits from one point to another point. So that much is done.
Maybe in metaverse, teleportation is possible at this point of time, but with quantum, it's still a long way.
Metaverse is all about your digital avatars.
All right, and I also encourage the audience to ask any questions. If you can raise your hand, we would definitely pick it up as well, because these are interesting topics, and obviously some of them are real-life examples as well. While we are still working on the quantum piece, definitely blockchain is something we can always pick up. One question on blockchain, Mr. Rajesh. Obviously, the SaaS that is out there, we are able to integrate. But can you give us insight on blockchain as a service? Who are the providers? How MSMEs can leverage it for their real-life use cases?
Yeah. So the good thing about blockchain is it's open source in nature. There are two options which are available in the industry today. One, if you have access to trained people, you can go to a GitHub or you can go to foundations like Hyperledger and then download the entire code. You don't have to pay even a single paisa of license fee. It's open source, open to use, and open to develop. On the other hand, if you're not able to develop it by yourself, there are managed blockchain services which are available by almost all leading players in the industry. IBM has a managed blockchain platform. Oracle has a managed blockchain platform. SAP has something called as a Leonardo. And VMware and the others are also coming up with their own managed blockchain services, which are available on a SaaS model. You can pay them a particular subscription fee. On a cloud instance, you can start using those blockchain platforms.
Sure. And while staying on SaaS, Sandeepan, I want to ask you a question around, of course, there is a heated topic around great attrition. But if we look at infrastructure as a service, the low-code, no-code opportunities like Mendix, leveraging Mendix and other tools, and also the SaaS that is available out there, do you think that because of the demand and the deficit around the talent, would that be the go-forward approach by the organizations?
See, the thing is, one of the aspects of what software truly is the best of us for the rest of us. And that's not limited to just software programmers. So what low-code, no-code does, it enables a lot of subject matter experts to use us as a tool to still leave an imprint of logic. And I think that's a great trend to come up to, and which is being enabled by this IaaS, SaaS, PaaS, and of course the low-code, no-code. So a lot of people who are in marketing don't need to work with a mathematician to make a marketing model, but include a SaaS model of mathematical modeling and try out and just figure out what is working for their real-life problems. A doctor does not need to know combinatoric mathematics, but can use a Monte Carlo simulation to simulate drug trials on a basis and use his expertise. So I guess that trend is a very healthy trend. Now coming to talent, talent scarcity is an economics problem. It's a demand and supply problem. The good side is that means a lot more innovation is happening, a lot more proliferation of technology is happening, and hence there's a shortfall. But where these things come to bridge the gap is, so many people not trained, so-called for software subjects, can still be really very relevant to software development if we propagate these things. Of course, performance is an issue, other aspects are an issue, but that can always be honed up. The entire process of innovation is if you try 10 things, probably 2 things need to finally go to the market. So instead of putting raw engineering talent on all the 10, which we were doing previously, if we can bypass the market demand needs by putting the next tier of subject matter experts and then prop up the 2 and then focus our technology talent on those 2, I think as an environment-wise we will gain significantly. The third aspect, of course, is, are we really training software engineers? I mean, anyone who's running a shop knows that we almost get, we only are recruiting for trainability and knowledge IQ, not really for skills. We have to develop that. So honestly, we are mostly recruiting people who we believe are able to learn fast than people who we believe know a particular XYZ subject. I mean, that trend has gone. Add to that technology obsolescence, even if they have learned something, Is it really going to be relevant in 2-3 year time frame? Forget 20 years. Every 18 months, something is changing. So what we are going to train our kids for, what we are going to train our people for, how we are going to augment their knowledge, I think that's a real challenge. Then we'll get the right people. Someone coming from commerce background can make a much better blockchain developer than someone coming from computer science background because they get it. And that getting it is more important from a common sense and knowledge perspective than that. But I think we have to redefine as to who is employable, who's trackable and not. Yes, the scarcity is there, but that's a great sign. It'll force us to look at ways we have not looked at, and that's where innovation happens.
Absolutely. Thank you. We have a couple of minutes left. If there are any questions from the audience, we'll pick it up. Okay, we are standing probably between lunch and the conversation. But, all right. Really appreciate the panel for talking to us about the various technologies and how the real life changes are possible through those technologies. I'm pretty impressed with what you bring to the table, Rajesh, be it blockchain or cybersecurity. And I would say while you are a startup with a good intention of more revenue and more opportunity, but you have a noble cause behind all this, Sandeepan, so thank you for what you do. And Mr. Rao Garu, we are always looking forward for future technologies and innovations. I'm sure just the way Gordon Moore said earlier, the processor speeds have doubled, the costs have halved. I'm sure this is a disruption from classical computing to the quantum computing world, and I'm sure we will see that light coming through in the next couple of years. So thank you.
So thank you, Sridhar Garu, and thanks, ICIA. To confess, after 2 years, I'm coming to a conference with my pant on and not the shorts, which was the case with regards to the virtual medium. And then it's also important to do these sessions, otherwise you will lose and forget the skill of conferencing. So thank you, ICIA, and thank you, Sridhar Garu.
Definitely, and thank you. And the fact that I'm starting to forget names, because now we are used to looking at the name on the Zoom and then talk to people. So it's a good comeback for me as well. Thank you. Appreciate all the time.
Thank you, Sridhar, for expertly guiding our panel and eliciting all those responses, which just go to prove that it's the tip of the iceberg. There's a lot more in terms of future technologies that industries and companies can experience. I'm going to request Mr. Kiran Cherukuri to join us on stage to felicitate our panel. Kiran is Vice President, HICIA, and CEO, Tech Era IT Consulting. If you could please step forward. Our moderator, Mr. Sridhar Chunduri. Then we have this one's for Mr. Rajesh Tuddu, VP and Practice Leader, Blockchain Cybersecurity Tech Mahindra. We'll move on to Dr. Panduranga Rao, Associate Professor, IIT Hyderabad. And then we have Mr. Sandeepan Chattopadhyay. MD and CEO of Self-Mock Design and Technology. And we could have the panel step forward for a quick photo op. Thank you to our panel for joining.